Okay, so module 5, as I told you, theory of games. The name of the chapter is theory of games. So what's the game? Okay, what's a game? In a business and economics literature, the term game refers to situation of conflict of competition. Okay, so there are two parties here, or two or more actually. Okay, refers to a situation where we are having competitors. So okay, in general term, it is called as a game where two or more competitors or participants are involved in the decision making process in anticipation of certain outcomes over a period of time. So here it so happens that there are many people, or we'll take example of two people. There's a situation or two competitors or two companies where they want to make a decision. So decisions could be like what product to launch. Okay, so what could be the price of my product? So these are kind of decisions where you need to take these particular decisions by looking into the competitors as well. What my competitor is doing, what features the competitor's product is having, what is the price of the competitor's product, and so on. Okay, so these are some of the situations where these particular games, we call them as games, but it's a situation basically. Okay, and participants or competitors, it could be two or many, so something like that. So the competitors are referred as players. So as we say the situation as game, the many competitors are called as the players. Okay, a player can be a individual, a group of individuals, or an organizations. Okay, so there could be one person, it could be group of people, or it could be an organization as well. Okay, so this is a game. So next, some of the terminologies. So what are terminologies? That means we use some words where you need to know what are those. So number of players. If a game involves two players or competitors, then it is called as two-person game. Okay, so two people are involved or two competitors are involved. It's called as two-person game. However, if the number of players are more, the game is referred as n person game. So two person game, many people, n person game. Okay, then sum of gains and losses. If in a game the sum of gains to one player is exactly equal to the sum of losses to the another player, that means there are, this happens in two player game. Okay, so if one is winning, that means the other should be losing equally. Okay, one is gaining something, that means the same amount the other person is losing. Okay, so if in a game the sum of gains to one player is exactly equal to the sum of losses to the other player, so that the sum of the gains and losses equals to zero. That means one person is gaining, right? Like for example, two people are there, me and one more person is there, and I am gaining some rupees 500, the other person is losing 500. So 500 minus 500 is equal to 0. My gains will be in plus, his losses will be in minus. So that is plus 500 minus 500 is equal to 0. So that is called as the sum of gains and losses equals 0. Then the game is said to be a zero sum game. Otherwise it is said to be a non-zero sum game. Okay, so zero sum game, non-zero sum game, where the sum of gains and losses equal to 0 is a zero sum game. Where it is not equal to 0, it is a non-zero sum game. So next comes strategy. The strategy for a player is the list of all possible actions, okay, that he will take for every payoff. That means there are different set of options for him to choose from. Okay, so what strategy, what option he is going to use, so that is one of the strategies. Okay, so that is what they are telling you. So list of possible actions out of which he takes. So those all things are called as different strategies. So strategy is one way which he is going to take a decision. Okay, the outcome resulting from a particular choice is known to the players in advance and is expressed in terms of numerical values. So example, money, percent of market share, or equity. That means uh, in earlier problem in some of the different units, if you might have seen that I had explained, like while going to college or going to home, the different situations. So these are the different examples. Okay, like where like you need to come to the college, like you were using bus, you were using your own vehicle, you were walking. Okay, so and the other situations where it was raining, it is sunny. Okay, so these are like some of the what do you call the situations where you are having different options to take. So you can take a college bus, you can take the government bus, you can take your own vehicle, you can walk, okay, or you can ask your friend to come and drop you. Okay, so these are all the different strategies that you are using, okay, different moves that you have to accomplish something. So your accomplishment was to come from your home to the college. So by what way you're doing it? Okay, so you you know it, and your all your friends know it, that these are all the different ways in which you can do that particular work. So similarly, when two people are playing, both the people know that what other strategies or what options each have. Okay, and if they take it, what is the profit or loss that is happening to him. So here two players, as I told you, so one player, if he is gaining, the other player is losing, right? So if the person who is gaining, he wants to gain as much as possible. The person who is losing, he wants to lose as little as possible. Okay, so if you are in that particular situation, if you are gaining, so you want to gain maximum out of it. But if you are losing, you want to minimize the loss, you want to lose as less as possible. So that is the strategy what these two players will basically have. One person who wants to gain more, he wants to gain as much as possible. But the person who is losing, he wants to lose as little as possible. So that is what is called as a strategy. The particular strategy which a player optimizes his gains or losses without knowing the competitor's strategies is called optimal strategy. That means a person or the competitor who is using a particular strategy without knowing what the other person is using. He will be knowing all the different strategies, but which strategy is using, he doesn't know. Okay, so at that particular time, that particular strategy is called as the optimal strategy. The expected outcome the expected outcome per play when players follow the optimal strategy is called as the value of the game. Okay, the expected outcome per play when players follow the optimal strategy is called as value of the game, v. So we'll see it later again, what is that. Okay, so you should know the outcome of that particular strategy. So he's getting some outcome, right? So that outcome is called as the value of the game. Okay, then types of strategies. We saw what is strategy. We are having two kinds of strategies. One is pure strategy and the other is mixed strategy. So what is pure strategy? So this is a decision rule that is always used by the player to select the particular strategy. That is the course of action. Thus, each player knows in advance all the strategies out of which he always selects only one particular strategy regardless of the other player's strategy. So what does this mean is there are two people and both the people know what are the different options available to both. But one person, what he does is he only uses one strategy. Okay, so he will not change the strategy based on the other person or the competitor what he is doing. He is not bothered about that, he is using only one strategy. Okay, so that is called as a pure strategy. So coming to mixed strategy, courses of action that are selected on a particular occasion with some fixed probability are called as mixed strategies. So in mixed strategy, we'll be having probabilities. Okay, so based on what the other person is doing, I am taking the action. So this is a mixed strategy. Like for example, he does something. So what is the probability of me exactly countering it and gaining the profits? So their probability is involved, and the strategy might change based on the other person what he is doing. Okay, so that is mixed strategy. Pure strategy, both the people are knowing the different options what they have, but one person using only one strategy. Okay, he has already made his mind. Let whatever the strategy the other person or the other competitor may use, but I'll be using only this. So this is the pure strategy. Mixed, based on what he does, I am taking a decision and there are probabilities involved. If I do this much of failure probability is there, this much of losses could happen, or this much of gains could come to me. So these are the probabilities which will be involved there. Okay, so this is called as the mixed strategy, pure strategy and mixed strategy. Now coming to flowchart of using game theory. So like the other way when we did the assignment problems, if you remember, so something this kind of flowchart was there. So here also we are using the same thing. Okay, the minimax and maximum method. Okay, so we'll come to that. So first let us see what it is. So write the payoff matrix. So what is payoff? The gains that what we are having, okay, the numbers what we will be writing in terms of a particular matrix is called as a payoff matrix. Okay, write the payoff matrix, then apply maximin and maximax principle. I just told you maximin and maximax, we just saw it in the assignment. Okay, so there in that assignment what you call module, so I had seen the maximin and minimax. So that same strategy or the same principles we are using here, so apply those, then see what happens. Is there a saddle point? So we'll come to saddle point, what it is. Okay, so is there a saddle point? You see, if it is yes, then identify the value of the game and write the optimal strategy of the players. So here, if yes, the saddle point is there, your problem ends here itself. Okay, if there is no, then is it a 2 cross 2 payoff matrix? 2 cross 2 means there are only four values in that particular what you call the matrix, that is two rows and two columns. Okay, not more than that. If we are having more than that, we need to make it to 2 cross 2. Okay, if yes, then solve by using analytical or algebraic or matrix method for fixed strategic games. If yes, directly go to this particular thing. If no, use dominance rules, okay, to reduce the size of the payoff matrix to either 2 cross 2 or 2 into n or 2 in, m into 2 size orders. Okay, so usually we try to bring them to 2 cross 2 or one of the side to 2. Okay, so that we are doing it here. So if yes, so is the payoff matrix, again we need to check. So I told you like the diamond shape. So this particular diamond shape what we are having, so this is drawn when there is a decision node. Okay, so here we are taking a decision yes or no. So here the square or the rectangle what you can see, it is just to show like write something to for you to know. Okay, here what we are telling you is do this, do that, that's all. Then after doing that, whether yes or no, it is positive or negative, greater than, lesser than, so at that particular time we are using this particular diamond shape in the flowchart. Okay, so here again coming here, so is the payoff matrix reduced to 2 cross 2 size? If yes, again go back here using analytical method or the matrix method, we are basically solving this sum. If not, so is payoff matrix reduced to a 2 cross n or n m cross 2? So 2 cross 2, if it is not there, have we reduced it to 2 into n or m into 2 size? If yes, use graphical method to solve the problem. If no, formulate and solve the problem as an LP problem. LP in the sense LPP, the first model what you have solved. LPP, linear programming problems. So LP, linear programming problem. So we have to make it into linear programming problem equations, then solve it accordingly. Okay, so that's how we need to do it here. So this is the flowchart. First check whether saddle point is there. So before that, maximum minimax we need to use. So if we get the saddle point, then it ends over there itself. Otherwise, bring the matrix to 2 cross 2 or m 2 cross n or m cross 2. If yes, you have brought it into 2 cross 2, go back to using the analytical methods and finish it off. Okay, if not, check whether it is 2 cross n or m cross 2, then use the graphical method. Okay, if no, if still you have not yet got 2 cross n or m cross 2, so what we need to do, we need to formulate the problem into a linear programming problem and solve it accordingly. So this is the flowchart. So next, two-person zero-sum game. So what is this? We just saw it. Okay, a game with only two players, say player A and player B, is called two-person zero-sum game. Only if one player's gain is equal to the loss of the other player. We just saw it, right? So that is one person is gaining, and if the other person is losing equal amount, then it is called as a zero-sum game. When there are two people and it is a zero-sum game, so we are calling it as two-person zero-sum game. Earlier we saw what is two-person game and what is zero-sum game. So here it is a combination of both. Two people are playing and one person's profit is equal to the one person's loss, then it is a zero-sum game. Okay, next moving to payoff matrix. So I need not explain much what is payoff. Payoff we have seen. Payoff in the sense it is the numbers where somebody is gaining or somebody is losing. But why I have put here is the only thing is when somebody is losing and the other person is gaining equally, So instead of taking two people's perspective, we are taking only one person's perspective. Okay, so here you will see the payoffs, a quantitative measure of satisfaction that a player gets at the end of the play in terms of gains or losses. When players select their particular strategies, okay, can be represented in the form of a matrix called as a payoff matrix. Since the game is zero sum, the gain of one player is equal to the loss of the other and the vice versa. So in other words, one person's payoff table could contain the same amount in payoff table of the other person with the opposite sign. That means if I am gaining here in one of the places, okay, take 500, I am gaining. Okay, the other person, the other competitor, you will be having in the same place, you will be having minus 500. So that is what they are telling. So what we can do is we can merge both. We can merge both the matrices, and here we can use only one matrix. So in other words, one person's payoff table could contain the same amounts in the payoff table of the other player with the sign change. So this is sufficient to construct a payoff table only for one player of the only for one of the players. That means if we construct my payoff table, that is equal to the other person's table, but the numbers are exactly opposite. Wherever there is plus, you need to put minus. So that means only one table can show you, or one matrix can show you both the person's payoff matrix. Okay, so that is what is important here. Okay, next coming to decision making environments. Okay, so there are three different decision making environments. One, decision making under certainty. Second one, decision making under uncertainty. And the third one is decision making under risk. But here we are only coming to the decision making under certainty. So uncertainty we have seen in that assignment problem, minimax, maximin, only two are there. There are different types of formulas to be used, okay, to get for uncertainty. But here we are only using the decision making under certainty environment. That is two things. There is no competitive situation, competitive situation. Okay, so are there any competitors, or there are no competitors? So we are coming to competitive situation. There are. So we have seen pure strategy and mixed strategy. So if it is pure strategy, minimax and maximum principle, directly saddle point, we are finishing it off. So mixed strategy, 2 into 2 order payoff matrix, 2 into n or m into 2 order payoff matrix, and m into n order payoff matrix. So again, in that particular flowchart, what you have seen, it's put it in diagrammatic format with the decision making environment. So 2 cross 2, what all are there? Algebraic method, analytical method, matrix method, and shortcut method. In 2 cross n and m cross 2 order payoff matrix, we are having only graphical method. In m into n, we are having the linear programming method. Okay, so this just now we all saw these particular things in the flowchart form. Okay, so if you see here in this particular flowchart form, we have done the same thing. So you see here they are putting here graphical method, use here, use LP method here, use analytical methods here. So that is only is given in this particular format here. Okay, using which kind of decision making environment we are, and what kind of competitive situation or non-competitive situation. In pure strategy, what we need to do. In mixed strategy, what we are doing. Okay, so this is the decision making environments. Now coming to assumptions of the game. So what are the, if you are doing something, there could be some assumptions. So if those assumptions fit properly, then only we can use these things. Okay, first assumption is each player has available to him a finite number of possible strategies or courses of action. The list may not be the same for each player. That means there are two players, A and B. One might have 5 different options, the other may have only 2 different options. Okay, that is possible, but they should be finite. 5 and 2 should be finite. It should not be one person infinite number of options and the other person finite. No, there should be always a finite number of possibles for both. Okay, both the participants or both the players or both the competitors, but they may not be same also. That's what, like 5 5 2 2. No, one person may have 5 choices, the other person may have only 2 or 3 choices. Okay, but they should end. That means there should be only a finite number of possible strategies. Then players act rationally and intelligently. That means they think and they use these strategies. Just like that, you're not putting any of these strategies. Okay, the list of strategies of each player and the amount of gain or loss on an individual choice of strategy is known to each player in advance. So that is what we are calling it as the payoff matrix. So for each strategy, what the person is making or the competitor is making, so what are the gains and losses? Both the parties know. Okay, so in advance they are knowing before taking this strategy only. Like before choosing it, they already know if they choose that particular strategy, what is the gain or loss for both. They will be knowing in advance. So one player attempts to maximize the gains and the other player attempts to minimize the losses. I just told you, right? If you are there in that particular situation, if you are A and you want to gain maximum. Okay, and you are player B, okay, and you want to, if you are incurring losses, what do? You try to minimize the losses as much as possible. So that is what they are doing here. Then both players make their decisions individually prior to the play. Okay, then without direct communication between them, that means without talking to each other, we are making our decisions or taking our decisions. Okay, prior to the play. Then after playing, we are finding out whether it is a saddle point is there, whether we are using pure strategy or mixed strategy, whether can we bring it to 2 cross 2 or n cross 2 and m into 2. So these things we need to find out here. Okay, so these are the assumptions of the game. Now pure strategies, minimax and maximin principles, games with saddle point. Okay, so here the selection of an optimal strategy by each player without the knowledge of the other player is the basic problem of the playing games. So if we already know what the other person is doing, that means we can take the countermeasure. But the game is played with the point that what the other person is doing is not known to us. Okay, since the payoffs for either players provides all the essential information. So in this situation, we know what the opponent, the different choices he has, what I have, and also what if he makes one of the decisions, what is the gain or losses for him, and what if I make a particular decision, what are the losses and gains for me. All are known prior. Okay, then therefore only one player's payoff table is required to evaluate the decisions. We just seen that by convention, the payoff table for the player whose strategies are represented by rows. Okay, so one person will be in row and the other person will be in column. So rows, for example, say player A is constructed. Now the objective of the study is to know how these players must select their respective strategies so that they are able to optimize their payoff. Such a decision making criteria is referred to as the minimax maximin principle. Such principle in pure strategy games always leads to the best possible selection of strategy for both the players. That means we are maximizing the profit also and minimizing the losses also. So this could be possible only in the pure strategy with saddle point. Okay, when we get the saddle point. So we'll see here. So maximum principle, I need not explain much. We have already seen that. Okay, so if you see, I have told you like go like this on reverse direction. That means find out the minimum of all the rows or columns. Then out of that, find out the maximum. So that is maximin. Okay, minimum of, sorry, maximum of all the minimum is maximin. So similarly, again, go from left to right. Okay, so minimax means first find out all the maximums of all the rows or columns, then find out the minimum out of that. Okay, so in this case, if you see, minimum of all the maximum values are called as minimax, and maximum of all the minimum values is called as maximin. Okay, so the saddle point is where we are getting both the values same. So in some of the problems there also, when I was solving, we are getting maximum min and uh, minimax values as the same. Okay, so that is called as the saddle point. Okay, so I will not explain much about this. Only thing is minimax and maximum you already know now. Go from left to right. Okay, from left to right. If sorry, from right to left. From right to left, if you go, you'll get. Okay, so that is minimum of, sorry, maximum of the minimum. First find the minimum, then out of that maximum. So that is maximum. Then the other one minimax. Find all the maximum values, then choose the minimum value of all those maximums. So that is mini max. Then optimal strategy, the course of action that puts any player in the most preferred position irrespective of the courses of action his competitors adopt is called as the optimal strategy. In other words, if the maximum value equals the minimax value, okay, then this particular game is said to have a saddle point or the equilibrium point, and the corresponding strategies are called optimal strategies. So whatever strategy the other person takes, you take one strategy and you are ending up at the point where you are getting the maximum profit or the minimum loss. So that is called as the equilibrium point or the saddle point. Now coming to the value of the game, we just saw written there value of the game if you remember. So it is also given as V. Okay, so this is the expected payoff at the end of the game when each player uses his optimum strategy. That is the amount of payoff is called as V, the value of the game at an equilibrium point. So the value at that equilibrium point or the saddle point is called as the value of the game, which is also denoted as V, capital V. A game may have more than one saddle points. A game with no saddle point is solved by choosing strategies with fixed probabilities. So we just saw mixed strategies. Okay, so there are mixed strategies where there are some probabilities involved, fixed probabilities involved. So including all those things, we'll be using the different values like the algebraic method, the graphical method, okay, or the linear programming problem, okay, LP problem. So we need to do those things if we are not getting the equilibrium point or the saddle point. So what is saddle point? It is the payoff value that represents both minimax and maximum value of the game. Both are equal at that point. Okay. So minimax is also we are getting the same value and maximum also we are getting the same value. This is called as the saddle point. Now coming to rules to determine the saddle point. So how are we determining the saddle point? So this is very important. So pay attention. So here the reader is advised to follow the following three steps in order to determine the saddle point in the payoff matrix. So what are those three steps? First one, select the minimum. Okay, select the minimum. I'll underline the minimum. Select the minimum, that is the lowest element in each row. So this is important. Minimum and row. Okay, maximum and column. So we'll see that later. So select the minimum element in each row of the payoff matrix and write them under the row minima. That means at the end, write minimum. Then write all the minimum values of all the rows over there under the heading row minima or minimum. Then select the largest element among those elements, then encircle in a triangle, rectangle. Okay, so what we need to do first, write all the minimum values of the rows, okay, under the heading row minima or the minimum. Then out of those values, select the maximum value and put a square around that. Sorry, rectangle or square around that. So next, select the maximum values, largest. Again, I'll underline the maximum value, okay, of each column. So maximum column, minimum row, remember this, of the payoff matrix, and write them under the column maxima or the column maxima or maximum you can write. Then select the lowest element among those and circle them, put them in a circle. Okay, so what we need to do, in row find out all the minimum values, then out of those minimum values find the maximum value and put a rectangle around it. Then second one, select the maximum of all the columns. Okay, maximum of all the columns, write them under the value uh, maximum or column maximum. Then out of those maximum values, select the minimum value and put a circle around it. Okay, so this is the second point. Third one, find out the elements that is same in the circle as well as the rectangle and mark the position of such elements in the matrix. So this element represents the value of the game and is called the saddle or equilibrium point. Okay, so what we need to do, we need to circle and rectangle, put it in that particular respective place. We'll see in the problem, then you'll understand. Okay, so we'll see a problem on this. So what is this? There is a problem for the game with payoff matrix. So this is the payoff matrix they have already given to you. So this is the payoff matrix. So this is the problem. So there is player A here. Okay, A1 and A2 is his strategies. Okay, player B, B1, B2 and B3. So if you remember, we have said that both the players or both the competitors may have different number of options. So in this case, see, A is having only two options, 1 and 2, but B is having 1, 2 and 3 options. Okay, so this is how the matrix is made. So these values are the payoffs. That is -1, 2, -2, 6, 4, and -6 are the playoffs. So what they are asking you, determine the optimal strategies for players A and B. Also determine the value of the game. Value of the game is asked in this game whether it is fair and strictly determinable. So fair in the sense, if it is a zero sum game, it is fair. If it is not a zero sum game, it is a strictly determinable. Okay, so that is what is the point here. So it is fair when if it is a zero sum game. That is when you add both the losses and the gains, you are getting zero. That means it's a fair game. If not, it's a strictly determinable game. If you are not getting zero at the end. Okay. So next, what is the solution here? So what we need to do? First, row minimum. Row minimum. What is the minimum here? -1 and 2 and -2. So out of this, which is the lowest one? -2 is the lowest one. We are putting here -2. Then 6, 4, -6. So what is the minimum value? It is the -6. This is the minimum value. Then coming to columns. So first column, what is the maximum? Maximum is 6. Okay, so just before coming here, just check out of this row minimum, which one is the maximum? So -6 and -2, both are minus only. The value with the lowest minus will be the maximum. So that's why we are putting this particular rectangle. Okay, so -2 is bigger than -6. So that's why we are putting this particular rectangle in that. Okay, and also put the rectangle here. So put the rectangle here also. So which number it is. So similarly coming to columns. So in column we need to take the maximum value. Row is minimum, column is maximum. So -1 and 6. What is maximum? 6. So we are writing 6 here. Under column maximum. Column maximum is written here 6. Then 2, 4. 4 is big. -2 and -6. -2 is bigger than that. So out of this, find out the minimum value. So out of 6, 4 and -2, the minimum value is -2. So circle that. Okay, circle that and also circle the value here. So the square or the rectangle and the circle, it should meet. So -2 and -2. Okay, and again they are meeting here. So this is called as the saddle point. So this is the saddle point, and the value of the particular sum is, or the game is, -2 is the value. You can see here the table. The quantity -2 in row A1 and column B3 is enclosed both in the box and the circle. Okay, so this is both the minimum and the both the minimum of the column, that is maxima, and the minimum of the row minima. Okay, so this value is referred as the saddle point. So that's what I explained. This is the saddle point, and the payoff amount of the saddle point position is also called as a value of the game. So for this game, the value of the game V is -2 for player A. So always we take in general as gains to player A and losses to player B. That means here if you see, if I put -1 here, that means -1 means B is gaining, A is in loss. So when we say +2, that means A is gaining, A is getting 2, whatever it is, like 2 amount or 200 or in thousands or in lakhs, whatever. 2 means positive, means A is gaining, negative means B is gaining. Okay, so that you should remember. Positive, A is gaining, negative, A is losing or B is gaining. Okay, positive, A is gaining, B is losing, negative, B is gaining, A is losing. So that is what they are telling you. For player A, B is -2. That means A is losing. The value of game is always expressed from the point of view of player whose strategies are listed in the rows. So always rows, if you see, row is player A, A1 and A2. So always the person which point of view you are looking at will always be in the row column. Okay, sorry, always in the rows, and the other person will always be in the column. Okay, so that's why they are telling you from point of view of the player whose strategies are listed in the rows. The game is strictly determinable because -2 and -2 is not equal to 0. Since the value of the game is not 0, the game is not fair. The game is fair, that means it should be a zero sum game. If not, then it is a determinable. So that is what they are giving here with the reason. Okay, so this is the solution. So we'll see one more sum. So one more problem, if you see what it is. A company management and the labor union are negotiating a new 3-year settlement. Okay, a 3-year settlement is there. Each of these has four strategies. So one is hard and aggressive bargaining, reasoning and logical approach, legalistic strategy, and conciliatory approach. So the cost to the company are given for each pair of strategy choosing. So if you see union strategies, so union strategies we are taking with respect to union strategies this particular matrix. That means positive means union strategy is gaining, negative means company is gaining. So these are the four different ways. So those are four different options for both. That is 1, 2, 3, and 4 for the company. 1, 2, 3, and 4 for the union. So what strategy will both sides adopt also determine the value of the game. So what strategy the company adopts, what strategy the union adopts, and what is the value of the game. So this is the question given to you. So strategies are given, four are there, where there is company and the union. So see the one of the example how it is, where there is a negotiation between two parties, that is the company and the union. That means workers union will be there, right? So the worker union and the companies are, and the company top level management there into negotiation. It could be for salary rate, like what you call more number of leaves or less number of working hours, okay, or increasing the wages, so something like that. So whatever is there, so there are four different things: hard and aggressive bargaining, the reasoning and logical approach, legalistic strategy, and the conciliatory approach. So these are the four options available to both union strategies as well as the company strategies. Okay, so both are there. Then what strategy will the two adopt? So they are asking what company will choose and what union will choose, and also what is the value of the game. So coming to the solution, what we need to do? Row, we need to find out the minimum. Okay, row minima is given here. Row minimum. So what is the minimum here? It is 12. So 12 is written here. Then here it is 8. It is written here. 12 is here. Then out of this 2 is written here. Then here it is minus 5. 0 is also there, but minus 5 is smaller than 0. So it is minus 5. So out of these, whichever is maximum, we need to put a square or a rectangle around it. So this is maximum of minimum. Now coming to column, find out the maximum. In this case, maximum is 40, maximum is 15, maximum is 12, and the maximum is 35. So out of the maximum, we need to choose the minimum. So 40, 15, 12, and 35, minimum is 12. We need to put a circle. So similarly here, for maximum we are putting, and for minimum both are same. So the square or the rectangle and the circle are coming at the same place. That means this is the saddle point, as well as the value of the game is 12. Okay, so value of the game is 12. So if you see here what is happening, so the company takes value 3, okay, and the union takes value 1. So that is what they are telling here. So what is this? So as shown in the table, since maximum is equal to minimax, the value of the game is 12. Okay, that is what is we have seen. Value of the game is 12. Therefore, the company will adopt strategy 3, that is legalistic strategy. The company is taking the legalistic strategy, and the union will always adopt strategy 1, that is hard and aggressive bargaining. So this is correct, right? So the company will try to be legally correct. So whatever they are doing, they will be legally correct. But what does the union try? They try maximum and hard bargaining. They want to increase, right? So if not, they also will go for what you call the strikes and all. So that is the hard and aggressive bargaining. So if you are not ready to do it, so if you are not ready to negotiate, we'll go on strike. So that is what the union does. And the company, what they do, they try to be legally correct. They don't want to go into legal battles, or they don't want to like go against the legal or the authorities basically. Okay, so that's why they try to be in the legal way, and the union wants to try as much as possible to get increase or whatever, for whatever the reason they are negotiating, they want to get the maximum. And even the company wants to be legally correct, and also should not want to give as much as possible. They don't want to lose more, and these people want to gain as much as possible. So that is what this particular problem will tell you. That means the company wants to be in the legally correct position, and the union wants to gain as much as possible out of the negotiation, and the value of this particular game is 12, and even that is called as the saddle point also. Okay, this particular point is called as saddle point, where both get agrees, and that value will be 12. Okay, so this is the value of the game. I hope you understood what is game theory. Not part of it. We have started the basics. Okay, the strategies, pure strategy. We'll go back and we'll just see. So what all we saw today. So what is game? Okay, two people are there. It's a situation basically. Two people are there. It's called as two sum game. If many people are there, it is a n game. Okay, it is called as n game. Okay, so that is what is written here. N-person game, two-person game. N-person game and two-person game. Sum of gains and losses. Zero sum game means if you add both the losses and the gains, it should be zero. Okay, if it is zero, then it is called a zero sum game. If not, it is called as non-zero sum game. Strategy, two types: pure strategy and mixed strategy. Pure, whatever the opponent takes the strategy, I am not going to change my strategy. So that is my pure strategy. So what mixed strategy is, based on whatever the competitor is taking the strategy, I'll be taking exactly like what it fits, and there are probabilities involved in this in mixed strategy. Then we saw the flow chart. So we have seen till here today. Okay, with the saddle point. Is there a saddle point? Yes, the game ends over there. If not, try to find out 2 cross 2 payoff matrix, or 2 cross n or m cross 2 should be there. If these are there, if 2 cross 2 is there, directly go to analytical method and fix the problem. If not, find it to m into 2, sorry, 2 into n or m into 2, then go for graphical method. If there also you are not able to get it, then you need to solve it using linear programming problem. Then 0% sum game we have seen, P of we have seen. Then decision making environment, certainty, uncertainty, and risk, non-competitive, competitive situation. Under competitive, pure strategy, mixed strategy. Under pure strategy, maximum, minimax principle, use the saddle point and finish the problem. If not, mixed strategy, 2 cross 2. If it is there, use algebraic method, analytical method, matrix method, and shortcut method. If it is 2 into n or m into 2, we have to go for graphical method. If it is into m into n order, then we have to go for linear programming problems. Then assumptions, we have seen that both the player should have what you call the finite number of possibilities. Okay, and it may not be equal to the number of situations for A should may not be equal to number of situations for B. Okay, they will be taking rational decisions. List of strategies for each player and the gains and losses are known in advance before starting the game. So one player attempts to maximize the games, and another person attempts to minimize the losses. Both players make the decisions individually prior to the play without the direct communication between them. So what strategy they want to take, they will not tell the each other, but they will be taking the situation, like the decision. Okay, this is the assumption. Then we saw what is saddle point, what is maximin and minimax principles. Then what is optimal strategy, what is the value of the game, the saddle point, the value at the saddle point is called is the value of the game. Then we saw what is saddle point, then what are the rules to get the saddle point. So minimum, always remember minimum to row, okay, and maximum to column. So row, always find out the minimum values, and out of that minimum values find the maximum value. Okay, for the column find the maximum value, and out of the maximum values find the minimum value, and one we need to put a rectangle and the other one we need to put a circle. So if both matches, that is the saddle point, and the value of that particular point is called as the value of that particular uh, problem or value of that particular game. Okay, so we saw two problems. So we'll stop for today. Okay, we'll continue in the next class. I hope you understood the game theory for two competitors, two sum game. Okay, students, we'll meet you in the next class.